For question 5, it looks like we need to review some of our definitions. And what I know about A is that tangent, I can rewrite that as sine theta over cosine theta. And if we multiply that by cosine theta, the cosines are going to cancel out. And we are just left with sine of theta. For B, what I need to remember is that 1 plus tan theta squared is in fact secant theta. So this is secant theta squared over cosecant theta squared. And I'm going to go back to, I know secant is 1 over cosine squared. Cosecant is 1 over sine squared. I'm going to get rid of these fractions. Why don't we just say we're dividing 1 over cosine by 1 of the sine. So that's the same as multiplying this fraction by sine. So that's going to give me sine squared theta over cosine squared theta, which just leaves me with tan squared theta. And yes, there are other ways you could have gotten there. For this, it sure looks like we are using some Pythagorean identities there. So what I know is that sine squared plus cos squared is equal to 1, but if I divide everything by sine squared, I get 1 plus cotangent squared is equal to cosecant squared. And if I divide everything by cosine, I have tan squared plus 1 equals sec squared. So let's see what happens here. So it looks like we end up with secant squared x minus tangent squared x. Secant squared x minus tangent squared x, well, that's 1. Then we're going to have cosecant squared x minus cotangent squared x. Cosecant minus cotangent squared is also going to give us 1. So we have 1 plus 1, and that's just going to give us a 2. For D, let's see, I'm going to go back to our definitions. So tangent is sine x over cosine x. Cosecant is 1 over sine x. Secant is 1 over cosine x. I'm going to multiply this fraction by sine x cosine x over sine x cosine x, because I'm just multiplying by 1. And everything in my numerator will cancel and leave me sine x. In the denominator, just cosine x will cancel, so I'll be left with sine x on the bottom. So that just leaves me with 1. And E is a little bit tricky, because who knows what to do with this. One option is to rewrite things as in terms of definition. So I could write this as 1 plus sine x over cosine x. And on the bottom, I have 1 plus cosine of x over sine x. I'm going to multiply top and bottom by cosine x sine x. So in my numerator, I get cos x sine x plus cosines cancel out, and I'm left with sine squared x. In the denominator, I get cos x sine x plus, and then the sines will cancel out, cos squared x. Let's see, I'm going to factor a sine x out of the top, which just leaves me with cos x plus sine x. In the denominator, I'm going to multiply factor out a cos x, which leaves me with sine x plus cos x. Addition is commutative, so those factors can cancel out. I'm just left with sine over cosine, and that is just tangent x.